Okay, we are continuing our lesson on fractions with prime factorization. This is part 1 video. I want to break this lesson up into 2 parts because I think it is so important for you to understand the vocabulary that has to do with prime factorization. It's going to help you understand why you are breaking down a large number. So let's get into the vocabulary that is so critical for you to understand. Prime numbers. Okay, this was a question that I asked you all. I asked you all if you understood what prime numbers are and composite numbers. So if you didn't understand it, well, guess what? This is your opportunity to learn what a prime number is. A prime number is a counting number, and we talked about that maybe the second week of school. A counting number begins with 1, and it's 1, 2, 3, 4, 5, 6, 7, and you just keep on going until infinity, or into infinity. So a natural number is greater than 1 that can be divided evenly only by itself and 1. There is no remainder with a prime number. A prime number has only 2 factors, itself and 1. And I want you to think about prime numbers. Think about the word prime. Think about primal or basic. So I want you to look at my picture of this ape, and I want you to think, what do you think of when you hear the word primal? You think of, something that is maybe not as intelligent, not just very basic. And I'm not saying that apes aren't intelligent, but compared to Homo sapiens, who can use a power saw or can code computers, that is something that an ape cannot do. So when you think of prime, I want you to think of a basic number. It only has 2 factors, itself and 1, and that is it. So I have a list of a few prime numbers here. So when you think of the number 2, the only numbers that can go into it are number 1 and 2. Same with 3, 1 and 3. 5, 7, 11, and 13. All of those numbers only have factors of 1 and itself. Here I have a list of 100 chart where all of the prime numbers are highlighted. This is something you definitely need to become familiar with. If you would like me to print this for you and you can keep it in your binder as a reference, I am happy to do that. As you practice prime factorization, the numbers mostly through 2 through 29 are going to become quite familiar to you. So let's keep talking about composite numbers. A composite number is a natural number, also known as a counting number, greater than 1, that can be divided evenly by some natural number other than itself and 1. A composite number has factors other than itself and 1. But I need you to know this about the number 1. The number 1 is neither composite nor is it a prime. Okay, that's just a rule you need to know. Composite numbers, here are some examples. So 4, when you think about the number 4, what can go into it? What are its factors? Its factors are 1, 2, and 4. The number 6 has a few more factors, 1, 2, 3, and 6. That is because 1 can go into 6, 2 can go into 6, 3 can go into 6, and 6 can go into 6. Okay? Same with 8, 1, 2, 4, and 8. And 10, 1, 2, 5, and 10 can go into 10. Now, if I ask you, what are the factors of 6? I would expect you to write the number 6 and then to list out the factors just as I did with commas in between each whole number. Okay. So let's go over prime or composite. Is 9 a prime or composite number? So 9 has factors of 1, 3, and 9. That's more than itself and it's more than 1, so it is a composite number. Is 17 a prime or composite number? 17 has factors 1 and 17, and that is it. So it is a prime. Is 45 prime or composite? 45 has factors 1, 3, 5, 9, 15, 45. So it is composite. Is 31 prime or composite? 31 has factors of 1 and only 31. And you're probably wondering, well, how can I figure this out? How can I figure out if it's a prime? Some of these numbers you will just memorize. The more you work with it, you're going to memorize that it is a prime. And then you can always go back to your multiplication factors. Think about, go through and just multiply some basic numbers and see how close, like if you were questioning, is 17 prime or composite? Think, well, 5 times 3 is 15, 5 times 4 is 20, and you can just go through your list. Go through 4s. 4 times 4 is 16, 4 times 5 is 20, so you know it doesn't have any factors of 4 or 5. And you can do the same with the numbers of 2 and 3, and just go through your multiplication factors and play with it. Okay, divisibility rules is really important for you to learn. You have a handout, and I want you to really read through this. This is going to be a lifesaver for you throughout pre-algebra, throughout algebra. You should memorize this now. This printout is going to be available for you to keep in your binder and for you just to go back to throughout the year. So let's talk about this chart. So divisibility rules, what is it? Divisible means a number is able to be divided evenly with another number with no remainders. Very important, no remainders. So a number is divisible by 2 if the last digit is an even number. Okay, so if you look at this number 2,458, 8 is divisible by 2 because 8 is an even number. And it should also add here that, I'm just going to write it in, that the last digit is an even number, or, oh, let me get my pen. Or 0. Okay, so 2 can go into a number that ends in 0. So 3, the sum of the digits is divisible by 3. So you actually have to add the digits, okay? So the number 123, you're going to add 1 plus 2 plus 3 equals 6. You know that 3 can go into 6, so 3 can go into 123. A number is divisible by 4 if the last 2 digits form a number that is divisible by 4. So let's look at this number, 4,524. Okay, we're looking at the 24 right here. 24 is divisible by 4. We know that 4 goes into 24 6 times. A number is divisible by 5 if the last digit is a 5 or 0. Okay, so 12,390 is divisible by 5, or 3,475 is also divisible by 5. 6. A number is divisible by 6 if the number is divisible by both 2 and 3. So that's really important to remember because it has to be divisible by both. So the number 24 is divisible by both 2 and 3. 2 goes into 24 12 times, and 3 goes into 24 8 times. Okay, so it is divisible by 6. 7. This one's a little more trickier. If you may have to reference your notes a few times before you memorize this one. You can double the last digit and subtract the sum from the rest of the number and set an answer that is divisible by 7. It's a lot of words. Let's break that down. So we have the number 672. We're going to double that last number 2. So 2 plus 2 is 4. And then we're going to subtract that from the first 2 digits, 67. So 67 minus 4 equals 63. And 63 is divisible by 7. That is 9, okay? So 8. A number is divisible by 8 if the last 3 digits from the number, that is divisible by 8. So 1,816. 816 is divisible by 8. And that might just be something you have to do on the side where you are, you might not know that by heart, and you just have to play with it. 8 goes into 816. Some of you might be able to see that 8 goes into 8 evenly and 16 evenly. So some of you may be able to see that right away. And if you don't, that's okay. You just do some math over on the side of your paper and work it out. So a number is divisible by 9 if the sum of all the digits is divisible by 9. So here's another divisibility rule where you're adding the sum of the digits. So 1 plus 5 plus 3 equals 9, okay? So 153 is divisible by 9. And 10, a number is divisible by 10. It's probably one of the easier ones to remember when the number ends in 0. So 257,890 is divisible by 10. I highly encourage you to memorize these rules. This is going to save you when it comes to dividing large numbers, and you're going to need to use it for prime factorization. That might be the end of my slideshow. That is the end of my slideshow class, so please take good notes. Take the time to learn this, and we will start part 2 of prime factorization. I will actually teach you how to do that the next lesson, and have a fantastic day. Work hard on your homework.